This is John Black, super chemist. We're here to make some glacial ethanoic acid, or you can call it, most people know it by glacial acetic acid. So I'm going to call it glacial acetic acid from now on throughout the video. And that basically, the glacial part just means that it's got no water. It's pure acetic acid. Now I dried some out, uh, and it always has lumps in it when you dry it out. I'm assuming that there's water in it. So what I do, I really don't need glacial acetic acid that much, but I'm doing it for this video because do need some acetic acid for my potassium dichromate video. So I'm going to get a little bit out of here just to do it, make it glacial. What I do is I get this. It's basically a strainer. I strain out the powder, just the powder. Now, as you can see, it's like a fine sugar. It's more like flour. See how there's no lump? It's like talcum powder. All right, I'm set up for distillation. In the pot there, you can see I have 164 grams of sodium acetate. I'm going to drip some sulfuric acid in there, 150 milliliters, and I'll do that not too fast. As you can see, it's right up there where the thermometer would be. And once I have it dripped in, then I will replace that with the thermometer. Um, there's my setup. It's just a basic, simple distillation. You can see that I got the funnel there. So if anything comes out, any vapors, it'll go through that funnel to the water and get bubbled out or scrubbed out. So here I am. I'm starting to drip it in. And pretty much as soon as you drip it in, it starts boiling. I mean, this stuff is, it's 80 degrees as soon as you start dripping it in. Vapors start coming, and you can see right there. Now, this took me about 45 minutes, an hour, something like that, to drip that in. And as soon as I dripped it in, I started to heat it up. Um, now, if you're now, I didn't use the powder in this video because I don't need glacial acetic acid. I just used uh, almost anhydrous, and I didn't use 98% sulfuric acid. So I'm just making concentrated. But you do it the same way. Keep in mind acetic acid boils at 118 to 119 degrees Celsius. So if you're doing glacial, you just boil off so you can see right here my front coming up. But you just boil off between 118 and 119, and you got your glacial acetic acid. Me, I'm taking everything because the only liquids in there are sulfuric acid and the acetic acid. And sulfuric acid boils at like, I don't know, 330 Celsius or something like that. So I'm not worried about that. And I did it at a pretty fast rate. It took me like maybe 2 hours to do this. And I did it twice, so it actually took 4 hours. Because I couldn't fit it all into the flask, and I didn't want to be there for 4 hours straight. As you can see, even on the other side, I should have used a bigger water condenser there. A lot of vapors made it past it. But I'll tell you what, I'm glad I broke the adapter that goes there, because normally you'd have an adapter and it'd go straight to my round bottom flask. But I don't have that. As you can see, what happens is the vapors get trapped up there, and they just get pushed through this little tube here when it drips, and basically all that fumes just go straight into the acetic acid that's already there. It dissolves right in it. So that's a great thing, because normally the tube would be up there on top and it would just escape right out into the atmosphere. This kind of makes it so it comes out and goes straight into the liquid. I kind of like this method here. See, about right there is where the hose would be coming out. Yeah, right there. And as you can see, all that smoke would be coming out that going into my funnel. I'd have to bubble all that and lose it. This way, it gets stuck there, and it only can come out that little tube. See there, that little tube inside? And then it has to make it back up to the funnel. So anyways, here we are about halfway through, and you can see it's boiling. The top is still hard as heck with wet spots. At the beginning of the distillation, I shake the whole apparatus. I just clamp onto it and shake the whole thing. And doesn't really do much, but it helps a little bit. And then I check all my joints, and then I start the distillation up. Like I said, I used a tiny condenser. I probably should have used a bigger condenser, but it really wasn't a problem. And like I said, I did this twice. The second time, I didn't even put sodium hydroxide in my bubbler over there where the funnel is. I just put plain water. And I'll tell you what, I don't even think I needed that funnel. And here we are. We're getting down to the last. You know when you're done, when all your stuff is falling into the liquid and it's mostly liquefied. Uh, other thing is it'll stop boiling because sulfuric acid boils so high temperature that it'll just stop boiling. And the third thing is nothing will be coming over. You know what I mean? You'll stop getting your acetic acid. You can see it's just puffing a little bit by a little bit because there's so little in the pot that it's just, you know, doing little puffs. See how it's starting to clear up on that side? Remember all the cloudiness? And now all the vapors are pretty much gone. And it's just dripping out acetic acid. I have a tin foil there to separate the heat from the cooling condenser, so I don't have to use as much ice. You can see there's really nothing coming out. There's like a drop every like minute. So at this point, I'm starting to give up. And whatever's in the pot, I just said screw it. Well, there you go. That's from. Remember, I did this twice now. I think the theoretical yield be 240 milliliters. So this is a 500 milliliter round bottom flask. As you can see, it's almost filled up. 250 would be half. So I did get about 240. So that was a decent yield. Keep in mind now, if you were making glacial acetic acid, you do it the same exact way, but you're going to get a smaller yield because this has some water in it. You know what I mean? But other than that, there's your yield. All right, glacial acetic acid or ethanoic acid. Um, it's just the same as alcohol almost. Here's alcohol, ethanol, vodka, and here's what we just made. See how it has two carbons? Two carbons. Two hydroxyl groups. Two. What the difference is this is oxidized. This has two hydrogens there, and this has two bonds to the same thing, an oxygen. So that's what makes that different. This now, if I had the potassium dichromate, or any kind of oxidizer, really a good oxidizer, I could just oxidize this to this, and I wouldn't have to do. But this is a different method here that we're doing. That's what this prefix ethanoic, ethanol, get it? Ethan, uh, two carbons. So, anyways, here's what we did to get our uh, acetic acid. Um, we got some sulfuric acid, and we just dripped it onto the sodium acetate. And you can see from how I did that, see how you got sodium sulfate, sodium bisulfate, because it took one of the hydrogens. Then you got the OAC, it took a hydrogen. So you got your acetic acid. And you can see from the words too, just take a hydrogen from here, you got your sodium, your sulfates from the sulfuric. Uh, anyways, you got, now, and keep in mind, I said this in the nitric acid video, 'cause I basically made nitric acid the same way. I dripped sulfuric acid onto a nitrate. And I think I brought it up about how this is acidic, but it's not really that acidic. The bisulfate has a pKa of 2, and the uh, first proton, or the first hydrogen on sulfuric acid, has a pKa of -3. So that's a big difference. I mean, those are by magnitudes of 10. You know what I mean? So even though it's a difference of say 5, each one of those is an multitude of 10. So keep that in mind. Um, that's a big difference in a pKa. Um, and actually, you got to be lower than -2 to be a strong acid. I mean, sulfuric acid just makes it in there, and then this does not. So it is not a strong acid. Anyways, so I take 1 mole per 1 mole. It's 53 milliliters per mole. I just use 95%. If you use 98, then divide by, if you're making glacial, you divide by 0.998 to find out how many milliliters. But I want to throw some extra in, so it doesn't really matter. So there's 56 milliliters per mole. I needed 2 of them because I put 2 moles of that in. That gave me 112 milliliters. That gave me 112 milliliters down there at the bottom here. And as you can see, I added in 150 just because it's a nice round number. I didn't want to put in a whole extra mole. So I ended up putting 38 milliliters extra in. That's 68% of a mole. So I put 2 moles in plus 68% of a mole. Because I have done this experiment a couple times before this, and it doesn't seem to give me a good yield. This time I actually got a decent yield. And so throwing a little bit in extra is pretty good. I didn't want to do a whole mole, so I like nice even numbers. Anyways, to move on. So I got 2 moles of this, 82 grams a mole. It's 164 grams. That's why I used that. A theoretical yield. This is 60 milliliters a mole times 2, because we put 2 moles in of the sulfuric acid and the sodium acetate. So that's 120 milliliters per each reaction. Because remember, I said I did this twice. So times 2 gives us 240 milliliters theoretical yield. And so I have 4 moles of acetic acid or ethanoic acid concentrated. And you saw before that it actually was pretty good yield. Now keep in mind, mine has water in it because I didn't use all powder like I showed at the beginning of the video. But the whole process is the same exact way to make glacial. Just make sure it's nice and powder with no lumps. Make sure your sulfuric acid is anhydrous, and you'll just distill it over between 118 and 119. You're going to have some glacial acetic acid. It's that simple. One last thing. Another way you can, if you have some concentrated acetic acid, concentrated ethanoic acid, you can always do this. All right, you can make reflux it with an anhydride. Now, what's an anhydride? A carboxylic acid anhydride. You take the carboxylic acid. I have 2 of them here. What we just made. Now let's say, look at how I have it. Look at the blue. What if I took an OH off of this and an H off of that, and I connected them together like that? That removes 1 water molecule, and that's how you get an anhydride. So if I reflux this anhydride with some with some ethanoic acid, and there's a little bit of water in there, the water will react with this to turn it back into ethanoic acid. So you'll end up with glacial acetic acid. And always remember, science is great.